Welcome to another video. Today we are going to be having a look at logic gates, something that in computer science is tested quite often. Now in the computer science syllabus you need to know 6 gates, okay, and they are as follows: the NOT gate, which is right here, the OR gate, the NOR gate, the AND gate, NAND gate, and XOR gate. Now in today's video we're going to be having a look at the logic gates, and we're first going to start with the explanation of all the 6 gates that you need to know, and then we're going to be following that with some past paper questions so you can understand this much more better. Okay, so let's begin with the first gate, which is the NOT gate. Okay, the NOT gate. The NOT gate is simply the easiest gate, so we're going to be starting with that. Okay, the NOT gate basically states that it is an opposite gate. Okay, what that means is that in logic gates, okay, we have two inputs. It can be either 0, it can be either 1. Okay, now in any logic gate question you'll be given this table. Okay, this table will look like this: 0 0 0 1 1 1 1 0 0 1 1 0 0 1 1, depending on the outputs. Again, that is okay, something like this. Now these ABCs is called the input. Okay, and for every input we have this sort of looking diagram. Okay, we have something that looks like that. Okay, so these are inputs basically, and the NOT gates will simply take that input and will give you a certain output. And in logic gates the main idea is to basically find the outputs of all the gates that are provided in your circuit. Okay, so that's the main aim. Now how can we do this? Okay, how can we do this? Now for the NOT gate, okay, let's go back to the NOT gate. The NOT gate simply says that when the input is 0, the output will be 1, the opposite of what the input was. If the input was 1, the output will be 0. Okay, now maybe you're not understanding what is this input and output. Maybe you're new to logic gates and you don't understand what's happening right now. Okay, now in just a few minutes we're going to be doing a past paper question, so you will understand everything there. But for now you just need to know that if the input is 0, the output is 1. If the input is 1, the output is 0. You need to know that for now. This is called the NOT gate. Okay, and it comes from the name not the input. It's the opposite of the input, and there's only one input possible in this gate, because you can see there's only one line entering this gate. That means you can only have one input entering this gate. Okay, so that is the NOT gate. Let's move on to the next gate. The next gate is the OR gate. Okay, we move on to the OR gate. Now the OR gate, I call it the addition gate. Okay, the addition gate. Now this is not the correct term, but I call it so it's easy to find out the inputs. Now here you can see we have 2 inputs. Okay, we have 2 inputs. That means that if I have 0 and 0, okay, if I have 0 and 0, okay, for example, let's say okay, for simpler terms, let's say this is A and this is B. Okay, so this is A and this is B. Now if A is 0 and B is 0, X will be the addition of these two, which is 0. Okay, and the next one can be, if it's 0 and 1, the addition will be 1, right? If it's 1 and 0, the addition will be 1. If it is 1 and 1, the addition will be 1. Okay, of course the addition of this will be 2, but remember in computer science we can only have 2, 0 and 1 for logic gates. Okay, so yeah, basically in simple terms it's like indirectly addition, but only up to 1. Okay, so that is the OR gate. Then that means that the NOR gate is the opposite of the OR gate. So if, for example, 0 0 was 0, for the NOR gate it would be 1. So basically the opposite of this. Okay, do not say it's subtraction. It is not subtraction. Okay, it is not subtraction, but instead it is simply the opposite of the OR gate. Okay, so that is that. The next one is the AND gate. Okay, the AND gate. So the AND gate. With the AND gate, again, we have 2 inputs, A and B. The AND gate, I call it, is the multiplication gate. That basically means I have to multiply the inputs. So that basically means if I have 0 and A is 0, B is 0, my x would be 0. If it's 0 and 1, it would be 0. 1 and 0, it would be 0. But if it's 1 and 1, it'll be 1. And that means the NAND gate is the opposite of the AND gate. So it's quite simple when understanding what gate does what, okay? And now let's finally move on to the XOR gate, and then we finally do past paper questions where you will understand what's happening, what's these inputs, what's these outputs. So don't worry if you don't understand right now. Right now you just need to know what these input output means, okay? But again, I will keep reminding you when we're doing the past paper questions. So you can memorize it later too. The XOR gate is simply, I call it the unlike and like. Okay, now these are all my terms. Okay, no one else in the internet calls it unlike or like terms, so keep that in mind. These terms are just so that you can understand the input and output. Now again, there's two inputs and outputs, so if it's A and B, so let's just write 0 0 0 1 1 0 1 1. These are the only possible inputs and outputs you can have. When it is a like, it will always be 0. Whenever it's an unlike, it will always be 1. Okay, there you go. That is how you understand it. Whenever it's a like, meaning it's 0 and 0, then it's always 0. Whenever it's an unlike, it's always going to be 1. So keeping that said, I have hopefully made you understand how the inputs and outputs work. Now let's have a look at some past paper questions so that you can understand further if you didn't understand this type of explanation. So here we have a question on the first logic gate problem. Okay, so this is question 5 of paper 1 2021 March edition. Okay, now usually logic gates are only tested in paper 1, so that's where you would most likely find it, around question 5 6 7, in the middle of the paper. So let's begin here. Okay, it says state the single logic gate that produces each truth table. Okay, and we've done this. Okay, let's see. 0 and 0, let's start with maybe the addition gate. Is it the addition gate? The addition gate is adding 2, so it's not the addition gate. Remember, the addition gate is called the OR gate. Okay, is it the XOR gate, which means unlike and like? Okay, unlike, is it unlike? You see, 0 0, it should be 0, so this is wrong. Let's see if it is the AND gate. Let's see if it's the multiplication gate. 0 times 0 is 0, so that can't be. Let's see if it's the NAND gate though. NAND gate. The NAND gate is the opposite of the AND gate. So if it was the AND gate, it would be multiplication. Yeah, it would be 0, 0, 0, 1. But again, look at here. It's opposite of this. So that means it's the NAND gate. So in this type of question, what you have to do is just test each and every gate. What I was talking about previously, you just have to test each and all of the gates, okay? Let's move on to the next one. Let's start with, is it the OR gate? Okay, the OR gate, remember, is addition. Okay, let's start with there. Is it addition? 0 plus 0 is 0. Okay, that's correct. Is it 0 plus 1 is 1? That's correct. 1 plus 0 is, that's correct. 1 plus 1 is not 0. So that's where I got it wrong. So it can't be the OR gate. Let's move on to, let's say, it can't be the NOR gate because again, it's not the opposite. Let's move on to the maybe AND gate. Okay, let's move on to the AND gate. AND gate is multiplication. 0 times 0 is 0. 0 times 1 is not 1. So it can't be the AND gate, it can't be the NAND gate. So the only gate that's left for us is the XOR gate. So the answer is the XOR gate, and let's see if it is the XOR gate. Remember, XOR gate says that like is equals to 0 and unlike is equals to 1. So like is 0, that's correct. Unlike is 1, that's correct. Unlike 1, like is 0, that's correct. Okay, so quite simple, very simple topic. The next one is another one. Okay, let's have a look at this. Let's start maybe with the AND gate. Okay, the AND gate is the multiplication. Let me just keep reminding you, multiplication. Let's multiply this. 0 times 0 is not 1, so there we go, it's wrong. It can't. Let's try the NAND gate maybe. The NAND gate is the opposite of AND gate. Let's see. So for the AND gate, it would be 0 here, so it's 1, that's correct, the first one. 0, so here is where it's wrong, it should be 1 here, okay? Because the NAND gate is the opposite of the AND gate. 0 times 1 should be 0, but it should be 1 here if it's the NAND gate, okay? So that's where it goes wrong. Let's try the OR gate. The OR gate is simply addition, okay? Addition of the two inputs. addition of A and B. Okay, 0 plus 0 is not 1, so there we go, we've already got that wrong. Let's move on to the NOR gate. The NOR gate is the opposite of the OR gate, and usually whenever we do the opposite gates, we first write maybe 4 OR gates. So let's start with the OR gate first. So 0 plus 0 is 0, 0 plus 1 is 1, 1, 1. And is it the opposite? Yes, it's the opposite. As you can see, it's the opposite. So that means it is the NOR gate. So as simple as that. The basic idea for this question is to test which gate it is, and you should get it done. Okay, now this is sort of a new type of question form. It never used to be there in the previous exams, but they have now introduced it in the new syllabus. So you need to understand this. Now, basically this is a word problem for logic gates. Okay, and it's a very simple thing. The main idea is just to highlight the keywords. So let's read this. An aeroplane, okay, has a warning system that monitors the height of the aeroplane above the ground. Whether the aeroplane is ascending, here we have a keyword here, ascending, descending, and the speed of the aeroplane. Okay, so we have 3 inputs, we can say. So these are the inputs. Okay, but here's the input. It's already telling us the input, so we don't need to highlight it. But if it didn't tell us, those are our inputs. Okay, the height, the ascending or descending, and the speed is our inputs. They're then giving us the binary value and then the condition. Okay, so now let's read the the statement. This is the most important part. This right here is the most important part. Let's read it. Okay, it says the warning system will produce an output of 1. Okay, an output of 1 which will sound an alarm W when either of the conditions apply. That means whenever it's 1, it will apply. Okay, it will apply, meaning it will happen. If it's 1, if the output is 1, if this binary value is 1, it will happen. Okay, so now let's do it finally. Now here, whenever they give you this statement here, this right statement here, you have to highlight the keywords. That's the most important part. So let's highlight the keywords right here. Okay, it says when the height is less than 500 meters, and so here's the first keyword, and gate. Okay, so let's just highlight that. Not seem to. Okay, let's just underline it. And is the one, and is the AND gate, then we have the OR gate, and then we have another AND gate. Okay, so we have 3 that we have found from here. Okay, now let's do the thing. Okay, and I'll also find a NOT gate, because remember, whenever it's not 1, then it's a NOT gate, right? So you'll understand it in just a second. Okay, yeah, so let's start. The first problem, let's tackle the first problem here. The height is less than 500 meters. Let's tackle that one first. Height is less than 500 meters. So let's find height is less than 500 meters. And I've found it here. The height is less than 500 meters and it's 1. That means that it will happen. Because remember it said whenever it's 1, it will sound the alarm. So when it is there, you just connect it. And remember it says and the aeroplane is descending. So and the aeroplane is descending. You can see aeroplane descending is 0. That means not 1. Okay, so not A. Okay, this means I do a not gate. Now it's advisable to use of course a ruler, but for saving time I will not use that. Okay, so this is connected with an AND gate. Okay, so because remember it's not A, not and H, okay, would give us the AND. The next one is saying, let's move on to the next statement, and this is connected with a OR gate, remember, so it will be an OR gate later. This statement and this statement will be joined with an OR gate later, but we'll have a look at that just in a bit. The aeroplane is descending, aeroplane is descending, so when we go to aeroplane is descending, that's not A again, so we will continue and say not A. Now what you can do for this is you can just do a line right here. Okay, and just connect it there. And S is saying, and the speed is greater than 470 knots. Speed is greater than 470 knots is again not S. Okay, so we will make another NOT gate, NOT S, and we'll connect this with an AND gate. Wow, that's a very bad looking AND gate, but hopefully you understand, because remember, again, it's connected with the AND gate. Now that we have done the two, and it's now connected with the OR gate. Now that's the main one, the OR gate, because remember, if I rub this up here, the OR gate is connecting this statement, statement 1 and statement 2. It's connecting statement 1 and statement 2. Remember how an OR gate looks like? It's important to know how each gate looks like. So, you know, for these types of questions, you can understand it. Now, there you go. That is how you do it. So that is how you do this question, and it's done. So it carries a lot of marks, as you guys can see, 5 plus 3, so 8 marks just for this question. So it's very important to understand logic gates. Let's move on to the next question, and so you can understand much more better. So here is a different type of question. Here we're given something called the logic statements. Now it's the same idea, just written in word form. Okay, so now I'm going to teach you how to approach types of questions like this. Okay, and then hopefully after understanding these types of questions, you can do any logic gate question with ease. Now in this video, I'm tackling one of the harder questions. That's why, you know, you can understand better with the easier questions. So that's why not all of these logic gates questions are this hard, but you know, it's important to learn the hard so that, you know, when you get an easier question, you can do it much quicker, and you know, you get it all right. So here is the logic statement. Okay, and they're given us some logic statements right here. They've given us a long, very long logic statement right here with so many and, or, and not, or not, and stuff like that. Okay, and we are supposed to make a logic circuit from this logic statement. Okay, so let's start with doing this. Now the first thing again in this type of question is to highlight the keywords, to highlight the gate. So we have the NOT gate, the XOR gate, the NOT gate again, AND gate, the OR gate, and the AND gate again. Now you can add them all up. 1, 2, 3, 4, 5, 6. So there's 6 gates that I will be having a look at. Okay, that's the first clue. So in your final answer, there should be 6 gates. Then you can find the inputs A, B, and C. Okay, so that means, but they usually always give it out here. A, B, and C is the inputs. Okay, they usually give this, so it's never a problem. But you know, it's important to know, you know, your inputs. Okay, so now let's start with the first one right here, A and B. You know, you can start with any. I'll start with A and B. Simple. Okay, A and B. So A is connected with B with an AND gate. Now sorry for the terrible drawing. In your examination, please draw carefully, but since I want to save time, I'm just gonna, you know, draw it like this. Okay, so we're done that. We are done that. So we've done the first one done. Let's move on to, let's say, this one now. I'm starting with the brackets only first. Okay, C and not B. Okay, C and not B. So not B will be connected like this, for example. Not B. So I would make a NOT gate. This is a NOT gate, and it's connected with just C. Okay, and it's connected. Ooh, very bad drawing. Okay, and it's connected with what? AND gate. So it's an AND gate. It's connected with an AND gate right there. So we've done that. Okay, here's the AND gate, here's the NOT gate. The 2 gates done. Here's the 1 gate, we did it. Now we move on to, let's say, which one can we do? Okay, so we've done those 2 now. Let's do the XOR gate, the XOR and the NOT C. Okay, so the XOR and the NOT C is connected with these 2 statements. Okay, let me rub this so you understand. Now the XOR gate is connecting this and this. Okay. Okay, wait. One second. Let's start with the OR gate actually, because remember the OR gate is combining this one and this one. So let's do that. That will be much more easier. Okay, let's start. We always pick the easy ones. You can do any order, but start with the easy one. So we do an OR gate right there. Okay, done that. This OR gate, remember, this OR gate is combining this and this, and we've done it. And now the final one is the XOR gate. So the XOR gate and the NOT C. So the NOT C, I can just do here, and the NOT C, I can do here, NOT C, and this is going to be joined by this and this. Okay, wow, really bad drawing, but there you go. Hopefully you understand that. There you go, and we're done with the logic statement. Now we can count how many gates there are. 1, 2, 3, 4, 5, and 6. We're done. Well, just let me make this much better so it doesn't look like a gate. Sorry. There you go. So 6 gates, we're done, and we remember we needed 6 gates. Let's move on to the next one, B. Okay, it says consider the completed truth table for the given logic. Okay, now for any of these questions, working space ones, what you first do is label each logic gate. Okay, so I'm going to label with a different color each logic gate. Okay, so this will be for 1, this will be 2, this will be 3, 4, 5, and 6. Now it doesn't matter the order, you can go left to right, right to left, doesn't matter. Okay, just label it 1, 2, 6. I've labeled it. Now I go to my working space and I write those logic gates 1, 2, 3, 4, 5, and 6, and then I draw just lines like this. Done. Okay, now it's quite simple. Okay, let's start with number 1. Number 1 is joined by A and B, and remember A is an AND gate. Now some people like to write, you know, the name of the gate on top so they don't get confused. You can do that. Let's do that. This is the NOT gate, this is the AND gate, this is the NOT gate, this is the OR gate, this is the XOR gate. Okay, now let's start with number 1. Number 1 is an AND gate, and it's A and B, those are the inputs. So we go to number 1, A and B, AND gate. AND gate is multiplication, so I'm going to multiply A and B. So 0, 0, 0, 0, 0, 0, 1, 1, because 1 times 1 is 1. We move on to the second one. The second one is a NOT gate, so that's the opposite of B. As you guys can see, it's the opposite of B. Okay, opposite of B. So number 2 is the opposite of B. So 1, 1, 0, 0, 1, 1, 0, 0. I'm just doing the opposite of this. We move on to number 3. Number 3 is an AND gate of number 2 and C. AND gate of number 2 and C. Okay, so let's multiply this. 0, 1, 0, 0, 0, 1, 0, 0. Okay, I'm multiplying the gate 2 and C. Let's move on to number 4. Number 4 is an OR gate of number 1 and number 3. 1 and 3 OR gate. So I'm adding 1 and 3. I'm adding 1 and 3. So 0, 1, 0, 0, 0, 1, 1, 1. Finally, okay, number 5 is a NOT gate of C. So the opposite of C. So it'll be 1, 0, 1, 0, 1, 0, 1, 0. And now 6 will be 4 and 5. 4 is going into a XOR gate, and 5 is going in as a XOR gate. So like terms is 0, unlike is 1. So 4 and 5. Okay, 4 and 5. Unlike is 1, 1, unlike is 1, unlike is 1, like is 0, unlike is 1, 1, 0, 1. There you go. This is my final answer right here. But remember, the question is asking us to find out which is the incorrect output. So let's have a look at this. Okay, so is this one correct? No, it's not. So the first one, row 1, is wrong. This one is correct. This row 3 is wrong. Okay, so this is wrong. Row 4 is also wrong. Okay, and row 5 is also wrong. 5 is also wrong. Row 1 is correct, correct, correct. So row 1, 3, 4, and 5 are wrong. As simple as that. So row 1, which one? Row 1, 3, 4, and 3, 4, 5 are wrong. So there you go, guys. Simple question, done. That was holding about 4 plus 6, 10 marks, guys. So 10 marks there. Again, logic gates are quite easy but very important to understand. So that will mark the end of the video. Hopefully you understood. Now I've done many past paper questions in other videos where I look at logic gates, so you can have a look at that. And in the future I will do more logic gates questions in upcoming videos, so have a look at that. So hopefully you understood this video, hopefully you enjoyed this video, and I'll see you in the next video. Thank you for watching, and I'll see you in another one.